Hello everyone! There are thousands of online resources for learning shaders. However, despite that, shaders still remain one of the most requested tutorial subjects. Now, having learned and definitely still learning shaders, I can relate to the struggle. You see, I've been so intimidated by shaders for like months on end, and I wasn't able to actually get started with learning them because whenever I tried, because I really wanted, because I really like shaders, but whenever I tried, it felt like I was just copying things on the internet. I didn't really understand what was going on. Like, I got the basics, but I could have improved, and I wasn't really satisfied with how things were moving. And yeah, maybe I just told myself, okay, shaders might not be for me. I will just leave shaders to some other smarter people. But in truth, after thinking a bit about it, I realized that there were three main things that were stopping me from actually learning. Now, the first and definitely most obvious obstacle in learning shaders is math. Now, I'm the kind of guy that really likes math, but even for someone like me, this was a big problem because I'm not using this kind of math on a daily basis, and of course, my morale went through the ground when I thought that I would have to pick books like this again just to get back on track with whatever I have forgotten from school. So, what is the solution for this? Well, to me, it seems like we are leaning too much in the math direction of shaders and not enough in the artistic side of shaders. So why think of writing shaders as putting together a bunch of mathematical functions in hopes that we get to the result we want, when we could actually think of them as image editing programs like GIMP, Photoshop, Clip Studio Paint, or something like that. So let's see an example. The mix function linearly interpolates between two parameters by using a third weight parameter and following this formula. That sounds terrifying! Okay, but thinking in more artistic terms, do you know what the mix function is? A gradient tool. The tool that you have in almost all image editing programs, in which you have one color and then another color and then a slider to pick between those colors. Now, I bet that the second option was easier to understand than the first one. And this analogy works so well because it works in reverse as well. You see, if you, for example, go to your favorite tool and want to create a new layer which has the multiply blending mode, that multiply blending mode is going to use multiplication in order to multiply the color of the pixels above with the color of the pixels beneath. If you want to apply layers to an image, then you are simply using an inverse lerp on that image. And actually, for pretty much all buttons that you see in those programs, there is almost always a math function that carries the hard work. So whenever you are editing images, you are actually secretly doing math. Okay, but I think you can see where I'm going with this. If we can take any kind of image editing tool and transform it into like a bunch of mathematical functions, then why don't we take shaders, which are a bunch of math, and transform them into a tool that has simply just a bunch of buttons that we could use in order to edit our image however we want? Alright, but thinking of shaders like that does not fully solve our issue, because even art software can sometimes be hard to use, and this is leading us to our second problem. Tutorials are too specific. Now, don't get me wrong. Many tutorials are absolutely amazing, and even some very specific tutorials can teach you a bunch of things. However, at least for me, I've noticed that whenever I wanted to do something in particular, I would fall in one of two places. I would either immediately find exactly what I was looking for, or I would not find the tutorial for what I wanted, and then I'd be either stuck or I would be searching for hours in order to find a way to achieve the effect that I wanted. So looking back at image editors, what worked for me was to go through the little tools in each image editor and to try to understand the most common functionality that they can do. And then the problem would just transform into finding ways of combining those functionalities, and I would usually be able to find some ways to achieve what I wanted. Well, it turns out that for shaders, the strategy works just as well. So if, for example, I already know what UVs are, and if I know the sine function, and then maybe the floor, and finally time, then I could combine those in order to get this interesting animation. That was pretty cool, right? So by this point, you might actually be quite excited about trying to work with shaders again. But there is still one last thing, and I'm raising three fingers, but it's one last thing, it's the third option. And the problem, the third problem is that writing shaders happens to be in a different language. So you're telling me that I've spent all of this time trying to learn GDScript or C# or whatever to write my Godot scripts, and now you want me to learn another language in order to write shaders? Yes. So yeah, it's true. Shaders are written in a different programming language. On top of that, whenever you search tutorials for shaders, you might be in the position in which you find tutorials for different kinds of shaders, not necessarily Godot shaders, so you might be finding glsl. Well, let me tell you, it's not as bad as it sounds. While the language might have some differences, at the end of the day it's just another language which has ifs and fors and while loops and so on, and it's actually derived from glsl, so whenever you find a tutorial that tells you how to write a shader in glsl, well, just as easily you're going to be writing that same shader in the Godot shading language because it's very, very easy to convert. So yeah, at most you're going to lose a few hours maybe to learn this final part, so it's not really that big of an issue. Alright, but I've been rambling for so long that my green screen budget started running low, so why am I even telling you this? Well, the truth is that I want to start a course that follows exactly these principles. So instead of going in depth into a specific shader issue, what I want to do is to go to the most common shader functions and to see their use cases, to see examples of them, and to also give you some exercises to make sure that you remember all that we learn in the course. And now the best part of all of this is that I want to make this course be absolutely and completely free, because honestly I am so excited about shaders, and I believe that many of you should be as excited as I am, because shaders are really amazing and can really bring life to your games or whatever apps you are developing. And because of that, all I need from you is to show any kind of support towards this video. And by support, I mean likes, shares, subscribes, you already know the drill, because I want to see how valuable such a course would be, and if it's not just shader rumors that Cashew here has been spreading in my ears. So, thanks for watching. I was talking, so yeah, thanks for watching, and I hope to see you in the next one. Bye bye. Bye bye. Bye bye. Oh wait, it's blurry. So, bye bye. Bye.